Hello, my name is Ethan Hunt, and today in this video we are going to discuss how to take data from a titration experiment, make a titration curve, and estimate the equivalence point on that titration curve. So the first step of this is to open up Excel, and hopefully you should have collected some data on your titration. We've got two columns here. We've got our volume of sodium hydroxide in milliliters, and then we've got the pH of the solution. And we can see we started with an acid, and as we added base into this titration, the solution becomes more and more basic. And we want to figure out where's that point, where's the tipping point, rather, where all the acid molecules equal all the base molecules, and the solution switches from an acid to a base. Now, looking at this data right now, it's very difficult just from looking at the pure numbers. So we're going to use Excel's graphical abilities to visually understand this data and learn where the equivalence point should be, or about where it should be. So to do this, we're going to make a graph using this data. And with Excel, what that means is we're going to select all this data here. So I'm clicking and dragging and selecting all the data here, including the headers at the top. We're going to go over to Insert here at the top column, or the top bar rather, and we're going to move over to this Charts section. Now right here, just above Charts in my version, you can see there's this this kind of axis with some blue dotted lines and some white lines, or dots rather. We're going to click on it, and we're going to click on the first option here, Scatter. So what Excel is going to do is it's going to plot each of these points on a graph and to make us our curve here. Now I'm going to make this a little bit larger just so you guys can see. Now what you'll see is that Excel, it'll make us this graph, but we want it to be an actual curve with like a single line rather. So what we want to do is we want to tell Excel to add lines between each of these points. So what we're going to do is we're going to double click on any point within this graph. This right menu should pop up. We're going to click on the paint can, and we're going to click on solid line. We can see Excel. We can close this menu now. Excel will fill in the lines between each of the points here. And now with our data graphed visually, we can see kind of a rough estimate of where our equivalence point should be. And we know it should be somewhere right here because this is where the solution was acidic and it started becoming more and more basic. And there's a point here where the solution switched from an acid to a base, and it became more and more basic as we added more sodium hydroxide within the solution. Now, to mathematically determine where this point is, we can guesstimate, right? Of course, we can say it's somewhere between 60 and 70, and it's somewhere between 8 and 9, or 8 and 10 pH. But to mathematically guesstimate this, maybe first we want to make our graph a little bit more easier to understand, to visually appeal. So what we're going to do is we're going to click on our graph. We're going to click on the plus sign here. This is where we can add in different elements to our chart to make it easier to read. We're going to click on Axis Titles. We're going to do this before we do any mathematical analysis, just to make it easier to read. And so what that does is this adds text boxes on the axes of this graph where we can edit in the titles of the axis. So for this x-axis here, this is going to be volume of sodium hydroxide in milliliters. And for the y-axis here, this is going to be pH. And up here, just to complete the whole package here, we're going to change the title of this graph to Titration Curve. Now that we've labeled our graph and it's a little bit easier to read, let's start doing a little bit of mathematical analysis, simple mathematical analysis, I should mention, to determine where the equivalence point is. And the way we're going to do that is we're going to look at the slope between each of these points on the graph. And how that's helpful is by comparing where the slope is the highest, right? Because down here, we can see that the distance between this point and this point is not very steep, right? It only goes up a little bit, but as we get closer and closer and closer to the equivalence point somewhere up here, we can see that the slope starts to really increase until it's almost vertical, and then the slope starts to die off. And we stopped collecting data in this experiment at 67 milliliters of sodium hydroxide, but if we continue to add sodium hydroxide, the slope of the between each of the lines here would continue to die off and get less and less steep. So somewhere here, the slope is the highest. And so we want to determine where that is using our data. And so over here in our Excel, we want to, oh, sorry, I noticed I made a typo here. This should be a lowercase p, ph. So in column C here, we want to add a new column to our data called slope. And just a review of how to calculate slope, that is y2 minus y1, all of that in brackets over bracket x2 minus x1. Right, slope is our rise over our run. It's our change in the y over the change in x. And so to calculate that in Excel, we can use formulas, the formula function in Excel. And how we're going to set that up is we're going to go bracket this value, so 1.85 minus 1.76, end bracket over bracket 1 minus 0. And it's very important that we add the brackets, right? Because Excel does BEDMAS. It's going to do brackets first, and then it's going to divide the two numbers. So once we have this, we're going to click Enter. And so this tells us the slope between these 2 points from point 1 and point 0 here is 0.09. So our pH increased by 0.09. Now, what we can do is we can use we can fill in this formula down the rest of the column by clicking on our new formula we created and hovering over to the bottom right corner. You see that your cursor turns to a black plus sign. And we're going to click and drag this cell all the way to the bottom of our data here. Let go. And what Excel will do is it will continue this formula throughout all of our data. So we can see if we click on any of these cells, it's going to take the point minus the previous point and figure out the slope between them. Now, your data may be, there might be a lot of repeated decimals, so what you might want to do is select all of the data, select all the formulas here that you created in slope, and press this decrease decimal button a few times so that each of these cells only has 2 decimal places. It makes it a little bit more easier for us to read. Now, initially looking at this data, this 15 may have caught your eye. What this means is that the slope here is very high, right? Higher than the rest. But say we wanted to graphically envision this. Say that, it's probably pretty easy for us to pick out the slope here with only, 70-ish values. If we had thousands, it would be very difficult. So what we want to do is, let's say, add another curve over top of our graph. So we're going to click on our graph, and you can see that Excel is going to highlight where the data is being pulled from to create this graph in blue. And so what we want to tell Excel is we say, hey, we've got some more data for you to add to this graph. And the way we're going to do this is we're going to, we've got this blue column here. We're going to the top right of the blue column until we see these 2 black arrows, diagonal black arrows. We're going to click and drag so that it also encompasses our new slope column. Let go. And you can see this graph automatically updates to incorporate the new slope column that we created in our information. And now it's pretty visually obvious to see there's a really big spike here, right? And this indicates that this is where our slope is the highest. And so what we can do is we can hover over this point, and we can learn exactly that our slope is when we add, you can see in the brackets there, our slope is exactly, our slope is highest at exactly 64.1 milliliters of sodium hydroxide. So what that means is, what we want to do then now is, now that we know that data, let's hide this orange column or this orange chart here so we can just see the blue. We're going to click on chart filters. We can see both of our charts show up here. We're going to uncheck our orange. We're going to click apply. It hides the orange chart here so that we can view our data here. And now we know that the slope is highest at this point. So let's go take a look at that point on our data. So we're going to scroll down and we're going to find this point here. So what this slope means is that to get from this point to this point and this point to this point, we have to jump up by 15. And so there are complex mathematical ways we can use to calculate the exact equivalence point, but we're only interested in about a rough estimate. And the best rough estimate we can do using this data is, let's just find the average between these 2 points, right? So this is the point where our slope was highest, our 64.1, and the point before it that was used to create the slope is the 63.9. So if we scroll back down to our data here, we're going to find our 63.9 and 64.1, and we want to find the midpoint between these two, otherwise known as the average between these 2 points. And so what we're going to do is we're going to add a little bit more data to this graph here. So we're going to click on row 69, right click, go down to insert. So it's going to add a blank row for us. And so what we're going to do is we're going to calculate the average between these 2 points and put it in this cell. So again, using Excel's formulas, we're going to go enter, bracket, this value plus this value, and bracket over 2. All right, and again, it's very important that we use brackets, right? Because we want Excel to follow BEDMAS, right? Where it adds the 2 values first before dividing by 2. Now, if we hit enter, we learn that our estimate equivalence point is at 64 milliliters of sodium hydroxide. Now, we're interested in learning what our estimate point in pH is. And luckily, we can just use the same formula that we created up here. And the way we're going to do this is we're just going to do the same thing. We're going to hover over the bottom right corner until we get that black plus sign. We're going to click and drag over to the next column here. And Excel will do the same thing. It will figure out the average between these 2 pHs to learn that the average pH is a 9.19. So we can highlight this data. I'm going to highlight it because this is our equivalence point, right? This is our rough estimate for an equivalence point. And what's cool is that if we go back to our graph here, Excel will automatically update our graph using the new data that we created. So we can see that Excel has now added a point at 64.919 that we claim to be equivalence point. And a rough kind of just visual check is that we can see that it's pretty even between each of these points, and this is a good estimate for where the solution switches from acidic to basic. So that's it for this video. Hopefully this helped. Thanks for watching.